The Gulf of St. Lawrence is a semi-enclosed sea located in the eastern Canadian shelf, which is the habitat of ecologically and economically important marine species. The Gulf of St. Lawrence is also the main waterway route in East Canada, connecting the Great Lakes region to the Atlantic Ocean. It is connected to the Labrador Shelf through the Strait of Belle Isle and to the Newfoundland and Scotian shelves through Cabot Strait. The Gulf of St. Lawrence is affected by large riverine input, oceanic and atmospheric forces, and sea ice. The presence of sea ice not only has practical implications for various economical activities taking place in this region, but also affects hydrodynamics and ecosystem dynamics there. For instance, sea ice in the Gulf acts to insulate the ocean from the atmosphere, modifying the air-ocean heat fluxes and vertical mixing. The presence of sea ice in the Gulf of St. Lawrence also modifies the characteristics of the wind-driven circulation in the region, since wind stress is not applied directly to the Gulf's water surface, but to the top of the sea ice. Both the salt rejection into the ocean during sea ice formation and the freshwater flux during ice melting affect salinity distributions in the upper layers of the Gulf of St. Lawrence, which in turn modify the stratification of the upper water column and the buoyancy-driven circulation in the region. Since the St. Lawrence River is freshwater for much of its length, it freezes every winter, at which time specialized equipment is required and specific safety regulations come into effect. Formation and growth of sea ice depends on the air temperature falling below freezing, that is 0 degrees Celsius, and subsequent lowering of sea surface temperatures. Sea ice growth usually starts sometime after freezing air temperatures are achieved, because the freezing point for seawater, which contains salts, is near minus 1.6 degrees Celsius and minus 1.7 degrees Celsius. In addition, warmer water from within the ocean may reduce the effect of freezing air temperatures on the surface water, further delaying ice growth. This diagram illustrates the median ice age positions of the east coast of Canada in the months of January, April, and July. The Gulf of St. Lawrence area covers the St. Lawrence estuary eastwards from Quebec, the entire Gulf of St. Lawrence, the waters south of Nova Scotia, and the waters south of Newfoundland eastward to the islands of Saint-Pierre and Miquelon. The first ice formation in this area occurs in the St. Lawrence River itself, normally during the second week of December, and the flows are carried downstream to the Quebec City area shortly after the middle of the month. This ice is thin and it is primarily a freshwater type, but it spreads downstream gradually, aided by wind and ebb tides. During the fourth week of December, this ice reaches the mouth of the Saguenay River and mixes with the ice forming in the salt water of this part of the estuary. The new ice formation occurs in the coastal areas first and then develops and spreads seaward. Due to the currents and prevailing west and northwest winds, ice growing in the St. Lawrence River estuary spreads more rapidly eastwards along the south side and reaches the North Gaspé Peninsula shoreline near the end of December. In the third week of December, ice begins to form in the coastal shallows of New Brunswick. In the last week of December, new ice starts to spread seaward along the New Brunswick coast and develops in coastal areas of Northumberland Strait. At the end of December, Northumberland Strait is partially covered with new and grey ice. The entire Northumberland Strait becomes ice-covered in the first week of January. During the last week of December, loose ends of new ice begin to form in the Strait of Belle Isle, as well as along sections of the north shore of the Gulf of St. Lawrence. At month's end, the highest concentrations can be found in Northumberland Strait, in the coastal areas of New Brunswick, along the south sides of the St. Lawrence River estuary and Shallow Bay, and in some of the coastal portions of the north shore of the Gulf. Most of this ice is new and grey and coastal fast ice outlines are being established. At the beginning of January, in the southwestern portion of the Gulf, the ice cover increases more in concentration rather than area extent. As the ice spreads away from the shore, the warmer waters tend to melt the ice. During the month of January, the growth and spread of ice proceeds eastwards across the Gulf more quickly than it progresses southwards from the North Shore. The ice concentrations at that time reach the very close pack range. Much of this ice remains as new and grey types, but grey-white now develops in parts of Northumberland Strait, along the south sides of the St. Lawrence River estuary and Shallow Bay, as well as in the southern section of the Strait of Belle Isle. During the second week of February, the ice drifting southwards through the Cabot Strait reaches the approaches to Sydney and lingers until the first week of April. The ice cover continues to grow and thicken as it spreads to cover most of the remaining areas of the Gulf by the third week of February. The exception is a 10 to 30 kilometers coastal lead along the Newfoundland coast south of Cape St. George. At the beginning of February, grey-white and grey ice generally predominates inside the pack, but thin first-year ice gradually develops during the course of the month. Over the northern portions of the St. Lawrence estuary and the Gulf, the predominant ice type remains new and grey. The reason the ice remains thinner over these areas is that offshore winds push the ice southward. From the later part of February until the middle of March, the ice in the Gulf reaches its maximum extent, and much of the ice continues to grow to the first-year stage of development. However, because of the continuous southward drift of the pack in the Gulf, the ice remains at the grey-white stage over the northwest portions. The lead along the west Newfoundland coast, particularly north of the Port-au-Port Peninsula, is closed and there can be ice drifting into the Cabot Strait. In the northeastern Gulf, the ice motion is much more restricted by the wind-induced drift from the west to the east, resulting in occasional congestion in the Bay of Islands area. Very large flows, locally called batures, are sometimes encountered in the northwestern Gulf of St. Lawrence in March. These are dislodged fragments of the fast ice which forms over shoals along the south shore of the estuary and which have been subsequently dislodged by spring tides during mild spells. Batures are noted for their sizes, roughness and dirtiness, and may carry a very thick snow cover that makes them very difficult to penetrate. They constitute a severe hindrance and a hazard to navigation. In the Gulf of St. Lawrence, the ice is mobile and free to move. Flows are generally smaller when compared with those found in the Canadian Arctic. Thus, ridging can be rather extensive in area but not developed to any great height. The height of ridging seldom exceeds 2 meters and is generally less than 1 meter. However, under conditions of extreme pressure along windward shores, such as the west shore of Newfoundland, ice flows may pile up to 13 meters above sea level. Puddling of the ice in the Gulf is rarely well developed. Dispersal of the ice begins in late February and is first evident in the estuary near the mouth of the Saguenay River, where ice concentrations fall to very open range. During the last half of March, decreasing median ice concentrations are evident through the center of the Gulf, but congestion persists in the southwestern portion and in the northeast arm. In late March, the estuary is usually free of ice and the thinner ice age has passed Anticosti Island. During the early days of April, ice in the main shipping route through the Gulf clears, separating into two areas: the southwestern Gulf and the waters surrounding Cape Breton, and the area from the Port-au-Port Peninsula to the Strait of Belle Isle. Once this separation has occurred, navigation in the estuary is unhindered and reformation of an ice barrier across the shipping route does not occur. The retreating ice generally melts northward during April and into May. By the third week of May, the sea ice has finally all melted, but icebergs can present a hazard to shipping during the summer. The date that the last ice clears can vary significantly. This diagram indicates the variability of ice extent on the east coast. The Canadian Ice Service provides accurate and timely information about ice in Canada's navigable waters. The following ice products are available during the Canadian ice season: ice applications and data, latest ice conditions, regional ice charts, daily ice charts, St. Lawrence River charts, iceberg analysis charts. Ice has always been a serious hazard to navigation. Extreme caution has to be exercised while navigating in or near ice-infested waters. The breach team should be apprised of the dangers of ice and actions required while approaching and navigating in such areas. Navigating officers should be fully aware of the latest available ice reports at all times. Past experience continues to indicate that a vessel in capable hands can safely navigate through ice-covered waters.